Hello and welcome to F12 Programming. My name is Mike Hewitt.
I'm Jacob Rains.
And what are we going to be talking about today?
Today we are talking about floats versus doubles, which I get a lot of questions about.
Which is very interesting because, most people just take one and go with it. But there really is a difference between all of them.
And decimals.
Yeah, it's just not a thing you just pick and go with. There's reasons for all of them. So which one are we talking about first?
I want to talk about floats first, and I'm going to kind of throw out doubles for the purposes of our conversation. The only difference between a float and a double is scale. And I don't remember exactly what the range on them is.
So doubles are very big numbers or very small numbers. A float is kind of in between.
So
we're not dealing with quadruple or like super tiny numbers. Most times we're going to be using floats rather than doubles. Is that correct?
Most of the time we'll be using floats. If you're working with doubles, there's got to be a really good reason.
Gotcha.
Because they're just astronomically large. But floats go up pretty big and pretty small.
Or astronomically small.
Or astronomically small. So we can make some really big and small numbers using floats. Matter of fact, even a float, I don't remember what the range is on them, but they go out pretty far.
Oh, yeah.
You're not going to hit an overflow on them with anything practical. Doubles are just unbelievably astronomical.
We'll have another video on that, right?
I don't know. Yeah, maybe. You're going to talk me into one, aren't you? So, but floats don't. They come with all kinds of consequences. So underneath the covers, they're fast. They're the way the processor wants to work. But they have an inherent bias towards 2-bit powers. So under the covers, when you see a float, and I can't do it in my head, but what it's really doing is something like some base times 10 to the power of some exponential number, and it takes so much memory for this and so much memory for the exponential, and it calculates out this number. And because this base, because we're doing everything off the power, these are all power of 2 base numbers, certain numbers work better than others. So if I say float F3 equals 0.5, I'm going to put an F after it. And by the way, I don't know if I mentioned that in .NET, C#, putting a number with a decimal place as a constant is assumed to be double.
But the float has to have the F behind it.
So we put an F behind the float. So
makes complete sense.
Yeah. Every now and then I'll see somebody do something like this. They'll do that, and they'll get an error because it'll put that little red squiggly there, and they'll say, "Oh, well, I just got to cast it to a float."
Yeah.
And it's like, the compiler is probably smart enough to correct that, but it really just needs to tell it right out of the gate it's a float, and then we don't have to cast it. So this works really well because 0.5 is 1/2, and you can imagine that means it's 1 divided by 2. It's a nice, everything's base 2 based. This will work just fine. But if we try to do something like 0.33, sometimes this will come up in code, and what you'll get is you'll get a value at some point down the road that looks like this. It'll say 0.32.
Right.
Or we've all seen this probably come up before, I would imagine. Or 3.00001, and it's because it can't quite figure out how to represent 0.33 based on the restrictions that it needs in the algorithm that's working behind it.
Gotcha.
And I don't want to get into the details there. I just know that it's not
so probably
always
not
perfect.
Very good for money.
It is horrible for money.
Okay,
absolutely horrible.
What would you use for money?
So for money, we use decimals.
And you'd put a D, right?
And we put a D. No, actually, we put an M.
Sorry.
Throw me off there.
Tricky.
That would make sense. No, D for doubles, F for floats,
and
M for money.
Yeah. Oh, M for money?
I think that's what I always say. They made it M. If you're doing money, you probably should be using a decimal.
Right.
Because
good little.
Because if it's checking account, and you add and subtract some checks off of it, and you end up with 33 cents and a billionth of a cent remainder,
right.
something's not working right,
Yeah.
and it's money. It's got to be right.
And I've seen that over and over in programs where I've come in and they're like, "What just doesn't work right?" And you find floats or doubles everywhere.
Yeah, and underneath the covers, a decimal is using an equation that is more like 1 bit for the sign times a base number times, I'm trying to remember, to the power of, I think it's something else. It's got some way more complicated equation running under the covers. But what it allows you to do is basically pick any value. It can't go to the astronomically small and it can't go to the astronomically large, but it's got a pretty broad spread.
So when would times you'd use a float for speed?
Use a float for speed, or when
you don't care as much?
when absolute accuracy and precision is not as important.
Okay.
I give you a great
Which
example.
sounds weird, but there are times definitely for that.
Often. So I mean, if you're working on a video game and you're trying to position a pixel on the screen during a frame that's only going to be there for a 60th of a second,
Right.
who cares if it's 0.06 pixels off to one? If we calculated the position off ever so slightly, no one's ever going to know.
Right.
But something like money, something that's transactional like that, we definitely want to use a decimal.
Makes sense.
And yeah, so like I said, the downside to the float is that you get these. Occasionally, you end up with these crazy, wild numbers, and also when we hover over a float, I find them harder to read because we get those. Matter of fact, let's just run this. Let's run a little Hello World console from one of our other videos here. And we don't even need to see the
Gotcha.
the console. I'm just going to move it to the back here. But if you hover over this F1 here, did I not hit a breakpoint? Oh, I got to hit the key. That's what you were saying. There we go. I was stuck up back here on my read key. So when I get down to my breakpoint here and I come back and I hover over this F1, it says 1E negative 21. That's not so bad, I guess. When you get a really complicated float, this starts becoming, I don't know, difficult to read. I mean, it's great to be able to tell scale. So if this says negative 21 and then another one says negative 18, I know the negative 18 one's bigger because it tells me how many, it's exponential. It tells me how many places we've pushed it off.
What does F3 say? I'm interested in that.
F3, actually, it came out right. That's not bad.
Okay.
I thought it might say something crazy. But,
Yeah. I thought so too.
And I need to take one more step here.
Which might be, but once you're adding and subtracting a bunch of
Floats?
yeah,
Yeah.
you'll start to get crazy.
Yeah, really quickly. If you do anything, you need to use floats for certain things like certain calculus situations or certain trigonometry situations where we're calculating sines and cosines and we're calculating the circumferences of a circle or something like that, where it's never going to come out to a decimal number anyhow.
Yep.
And then you expect it to be some wild number. So
Anything else?
no, I mean that's the high level overview.
So use decimals when you really need precision. Money, definitely. You don't want to skim somebody money.
Use float for speed.
Yeah. So,
Yeah, and if you're doing something where you're doing a comparison, like you're saying you have an if statement somewhere in your code that says if this value equals this value, and it's a float, you're kind of inviting mistakes.
yeah.
Because the odds of them actually being equal are pretty slim.
Right. That makes sense.
Thank you for watching that video from F12 Programming. Please remember to like and subscribe. That does so much for us in the ratings. You have no idea. Also, don't forget to comment below. I hope you enjoyed, and good luck coding.